Assalamualaikum, dear students. Today we will learn about matrix inversion method. In this method, we have two equations. These equations are basically simultaneous equations. We solve these two equations by matrix inversion method. As you see, we have two equations: 3x minus 4y is equal to 4 and x plus 2y is equal to 8. First of all, we write these equations and we give it numbers. This is first equation and this is second. Now I write coefficient of variables. We have two variables in this equation. First is x, second is y. In first equation, variable x have coefficient 3 and variable y has coefficient minus 4. Similarly, variable x have coefficient 1 and coefficient of y is 2. I represent these four elements into matrix form. Now we have two variables right in matrix form: x, y equal, we have two constant 4 and 8. This is our matrix form of the equations. Now we solve these matrix. I represent first matrix as A, second matrix as x, and the right side is equal to b. I have to calculate x. A inverse is equal to b. We shift A to the right side of the equation. First of all, I calculate A inverse. As we know in the previous lecture, A inverse is equal to adjoint of A over determinant of A. First, I calculate determinant of A. Determinant of A is equal to 3 minus 4, 1, 2. Now I calculate determinant. I multiply diagonal with each other. 3 multiply with 2 and 1 multiply with minus 4. And a minus sign between these two multiplications. This shows that it is determinant. A determinant is equal to 3 2s are 6. Minus 4 multiplied by minus 1 is equal to minus 4. And this minus, it makes it plus. Determinant of A is equal to 10. If determinant of A is equal to 0, then its solution is not possible. Since its determinant is non-zero, so solution exists. Now I find adjoint of the matrix A as A is equal to 3 minus 4, 1, 2. Its adjoint of A is equal to, I shift these two diagonals, 2 replace with 3 and 3 replace with 2. Now other element which are non-diagonal, I change their sign. 1 become minus 1 and 4 minus 4 become plus 4. This is our adjoint. So A inverse is equal to adjoint of A over A determinant. A inverse is equal to adjoint of A. I write A determinant is equal to 1 over 10 and adjoint of A is equal to 2, 4, minus 1, 3. As I told you earlier that x is equal to A inverse B. X is equal to A inverse B. So x is equal to A inverse 1 over 10, 2, 4, minus 1, 3. And what is B? B 4, 8. Now I multiply these two matrices. Multiplication of matrices is, as we know, row multiply by column. So 2 multiply with 4 and 4 multiply with 8. and second row is minus 1 and 3. So minus 1 multiply with 3 and minus 1 multiply with 4 and 3 multiply by 8. X is equal to 1 over 10. 2 4s are 8. 4 8s are 32. Minus 1 multiplied by 4 minus 4. 8 3s are 24. X is equal to 1 by 10. 8 plus 32 is equal to 40 and minus 4 plus 20 is equal to 20. Now X is equal to 40 by 10 and 20 by 10. X is equal to 40 by 10 is equal to 4 and 20 by 10 is equal to 2. Now capital X is equal to 4 and 2, but capital X is equal to small x and y. Now what is X? Compare these two matrices. So X is equal to 4 and y is equal to 2. This is our solution. X is equal to 4 and y is equal to 2. Now we can check our answer. The method to check answer is that put these values in any equation. We have two equations. First equation is 3x minus 4y is equal to 4. Replace x with 4 and y with 2. 3 4s are 12, 4 2s are 8. 4 is equal to 4. Left hand side is equal to right hand side. So our solution is correct. So we can say that solution of these two simultaneous equation is x is equal to 4 and y is equal to 2. I hope you understand this matrix inversion method. If you have any query about this topic, then comment please and subscribe my channel. Thank you.